Hi, I'm Rotem Gutman.
I'm Gabe Samlo.
And so, Gabe, I understand that you've taken the internet and shoved it in a box.
Right, on the IT crowd.
Yeah, exactly.
It's
and so,
not actually got. It doesn't have a blinking LED on it.
There's no red light on the top?
Nope.
Then why even do it? I mean, at that point.
I'm sorry. I apologize. I should probably fix that as soon as possible.
So before we get to the how, because I do want to know that, but why? Why would you do this?
Why not? No.
See, this is how you get in trouble.
Right. So we have a lot of, I don't know, are we, geez, man, I don't know. I mean, you're asking me this question, so I now have to go back and sort of give the official spiel of, okay, we're doing exercises, we're simulating offensive, defensive, cyber forensic scenarios to teach people hacking skills and defense skills and forensic skills. Okay, so when we're doing that, we do that with a lot of VMs, and so because we do that with a lot of VMs, and the VMs run on platforms and environments that are disconnected from the internet for multiple reasons, because they happen in secret installations that are air-gapped, because we don't want our viruses to escape on the internet. And then we want the trainees to think, or to sort of have the sense of realism that they are on some sort of thing that looks like the internet. So we scraped all the websites that we thought people might sort of be interested in for realism's sake, and we set up a bunch of other services that might look like they are out there on the real internet, and shove them in a single VM to make it easy to start and stop a simulation.
So that's the first piece of it, was just the websites. Trying essentially, so when somebody's training their cyber skills in an environment that is safe and secure, so that anything they do doesn't get out on the public internet, they still have access for the sort of look and feel for as if they were on the public internet from the perspective of websites.
Right. You basically, the sort of prime directive was, hey, we have all these web servers in our simulation, and they're all burning up a special VM for each one of them, and that gets heavyweight really fast the more sort of realism and the more websites you want people to think they have access to in their games. And so obviously for a very long time, website operators have been doing virtual hosting. So you have a web server machine or sort of an installation serving 3, 4, 10 different companies' web servers, and that's called virtual hosting for the web. And that's been done on the internet since, the web server was invented. And so I thought, hey, wait a minute, right? I mean, if we want 500,000 websites, can't we just host them off of the same server? So the answer to that is obviously yes. It is just a matter of how much space you have on your hard drive, because your root directory for the web server software could have 10, 20, 500,000 subdirectories, and you could just put different websites in there.
Except for now, when you're looking at it from a network security perspective or from a network forensics perspective, I mean, you can tell these are all being hosted at the same site. So that kind of ruins the realism when you're trying to go to this website that's in one country or this website that's in another country, and they're all coming in off the same pipe.
Right. So we're never going to get over the fact that these aren't going to be actually, they're like NPC characters in video games. They're not actually hackable websites, because if you hack one of them, now you've hacked every web server on the internet, so they're all served out of the same actual server. But we could make them look like they're in different places. First thing, we could have different IP addresses configured on the same server. So if you go to IP address 1 for web server 1, you can go to IP address 500 for web server number 500. So they're actually pretending to be coming back at you from different IP addresses. True, the IP addresses, they're all in the same box, but they're coming back from the same.
But then if I start doing, let's say I just start tracing routes to those IP addresses, I'm going to see they're all being served off the same route.
Right. The trace route to all websites is exactly the same. So for that, then you need to add routers virtual routers. And we had virtual routers too, separate virtual machines, many different VMs running Quagga, which is Linux, the Linux package that does sort of upscale routing protocols, not just sort of the bare bones stuff that you get on a user machine. So running Quagga in a VM, running Quagga in another VM. Now you have two routers. You have, I don't know how many routers do you want to start getting a feel for a realistic VM. You have the scaling problem again. You have like hundreds of virtual machines in an exercise that aren't dedicated to the students logging in and for doing forensics or defensive or offensive cybersecurity. It's just NPC machines sitting around there to pretend to have, so you could pretend you have a routing infrastructure.
So to take the video game analogy of NPCs, this is, you're dedicating all of these resources, and it's not for the player character or the interactable characters. It's just for the background.
Paint the background picture, right? Mm-hmm. So we could probably, I mean, we thought we could do that more efficiently. So Robert Beveridge and I were sitting in the hallway a few years ago, and we were thinking, hey, wait a minute, wouldn't it be nice if we could have all the routers on the same machine? And then I said, well, we should probably be able to do that with containers. And if only somebody wrote a simulator, a network simulator that was using containers. And then like all brilliant ideas that I have, typically a Google search will sort of disabuse me of my brilliance and sort of thing. It's been done by somebody somewhere, right? If it's
or at least really useful. Or at least the 80% solution is right. Somebody started it.
So I Googled around for container-based simulators, and the thing that I found that was the most elaborate and sort of almost 95% ready to go was CORE. CORE stands for Common Open Research Emulator, developed by the Naval Research Lab in collaboration with Boeing. Open source project on GitHub. Download the thing, install it. I made it into an RPM because I'm a Fedora nut, so I decided I'm going to use Fedora for most of the things that I do. So I made an RPM, installed the RPM, and then the question was, we just needed to come up with a map, an actual, like a configuration file for the simulation that has many BGP routers and the application service in there, like the websites and everything. And so now you have a single machine running the simulator with containers. They're very lightweight containers, by the way. You don't want to wrap a heavy duty sort of lots of files, Docker file thing around just Quagga, because it makes no sense. Quagga comes as a package on your Fedora installation. All you really want.
I'm just trying to do the routing here.
Is wrap some fake network cards around each Quagga process that shares the same kernel with your one internet.
So how many BGP speakers do you have?
The thing that we do currently has 69 or 70 plus one machine that runs, or one container that runs the websites.
And so you picked, using this CORE simulator, you picked that one because it was open source, correct?
Well, yeah, I sort of generally tend to prefer open source software for everything that I do, mainly because it's just easy to find. There's no process to obtain it or to pay for it. It is very easy, and then sort of it's easy to contribute back to it. And the reason why you want to contribute back to open source software that you use professionally is typically if you make changes to it, okay, now the changes are yours, they're local, they're your it could be your secret sauce, or it could be just something that's a burden that you have to carry forward as the upstream package evolves. It tends to evolve away from the change you made unless you put the change back and talk to the maintainers and contribute it back. So that now it's kind of part of the project, and when they make changes to it and the software evolves, it actually evolves with the feature that you want it to have, and you're no longer responsible for reapplying your changes over and over as new versions get released. So,
as you said, this was, your 95% solution, but that 5% that you added then gets merged.
Yeah, it had some warts that I fixed and then contacted the developers and pushed the fixes back upstream so that I actually don't have to worry about them anymore, because I would continue to have to worry about them if I didn't do that.
Yeah, every time we updated it, we'd have
Every
to
time
reapply
every time we updated to their latest version, I would have to rebase the patches and figure out where they don't apply cleanly anymore and keep dealing with the same issues over and over. And once you've submitted the fix, obviously you're going to deal with new regressions and with new issues that they introduce, but that would happen no matter what. You're no longer going to have to deal with your old issues that you already fixed, right? So
just the new things that are broken.
Right. So things that you fixed tend to stay fixed if you submit upstream. Otherwise, they don't. They just keep coming back.
And so now that you have that system up there, now, as we know, websites aren't the sum of the internet, right? So we needed a little bit more realism there. It's not enough to just visit websites. We need other interactions happening there. So we have the background scenery, we have the hills, the mountains, and the streams, but we need some trees, some birds.
There's DNS. That's one of the big ones, right?
Because how are you going to find the websites?
So you need to translate names of websites, among other things, into IP addresses. So that's what DNS does. The problem is, right, like the internet has a whole giant DNS infrastructure. It's not just the one name server that your company runs that helps you find things. It has to go and talk to a lot of different servers, starting with the roots and the top level domain servers and so on, to find some authority that can answer whatever query, whatever DNS translation queries the client comes up with. And so just like there's a bunch of websites that you want to have in your pretend internet, there have to be DNS server infrastructure components in the pretend internet to help your name server find answers. And interestingly enough, just like Apache and Nginx and sort of HTTP daemons can do virtual hosting, and essentially that means they have multiple personalities. You can configure them to pretend to be different websites depending on how you talk to them. The same thing applies to named or bind the DNS server infrastructure, except they don't call them vhosts, they call them views. And generally speaking, a DNS view is used to selectively tell different things to different clients. If you're the server and you have like a DMZ or an external presence, and people from the sort of internet at large come and ask you questions, you may tell them only about your DMZ machines, like your public web server and your public infrastructure that you're offering to the outside of the internet. You may have a private network that's not visible to the outside, and to that private network you may tell more things about more services that you have on the inside.
I don't want everybody on the public internet to know that I have, db dot whatever as my backend database server, but I still want to be able to use that URL internally to access it.
So generally a DNS view is a virtual hosting option for DNS that allows you to discriminate against the clients, where they come from. Are they your trusted internal clients, or are they just sort of random people on the internet asking you questions? You could treat them differently based on where the query comes from. But interestingly enough, there's a facility in the configuration file of the DNS server to discriminate not just based on the source of the query, but on the destination of the query.
Nice.
So if you have, like with the websites that we did, multiple IP addresses configured on your machine, you have a machine with 20 different IP addresses, you could discriminate between DNS queries based on which of those IP addresses of yours they're talking to. So you could pretend to be a different kind of server depending on who the client thinks it is talking to. So just like with websites, now we could be the root DNS servers.
Yeah, if you're coming in
through mroot, If you think you're talking to a root server when you're addressing me, then I'll act like I'm a root server. So I'll be whoever you want me to. Right? And then I'll tell you, go and talk to like DNS delegation. Like the root will tell you, okay, now that you want something .com, I will forward you, or I will tell you, I don't know the answer, but go talk to the .com TLD server. And when you try to talk to that server's IP address, guess what? That's me again. I'm just going to now put on my domain hat and
it's like a bad comedy sketch. It's like, no, you need the manager for that. Comes back with the
manager hat and everything. So that is essentially what this project is. It is websites, DNS servers, mail domain servers that change their hat basically depending on who the client thinks they're talking to. So that's how you get away with just one single virtual machine for everything.
And for some of the more esoteric but still important use cases, like having blockchain running so we can do cryptocurrency.
For those kinds of things, you actually want not just those aren't NPCs anymore. Those are active participants, yes. So they could be their own container, but still run on the same machine. You can have, or we do have exercises where the simulation also has wired into this multiple router container plus application server infrastructure. We have maybe 4 or 5 onion nodes with a special in-game directory authority, because we can't fake the real directory authority. If we could do that,
that would be bad.
The internet would have a big problem. So we have to use our own in-game directory authority. And so if you want to participate in this, you have to download the configuration file from the landing page web server that has all the information inside the simulation. And so if you set up your onion daemon with that configuration file and you make it trust my in-game directory authority, then you could actually pop out from one of the nodes in the simulation.
And in this particular case, though, to take the example of mining cryptocurrency, it could actually be useful for the exercise and for the training to have a smaller set than realism. So if I want to have somebody do a 51% attack, that's going to be hard on a
it's always easier to do a 51% attack when you have 5 Bitcoin miners in the entire internet, right? All you have to do is like take over.
We've seen that in the real world in the actual 51% attacks that have occurred lately, because against some of the smaller cryptocurrencies,
that's what you get with the fragmentation, right? So like if for instance the original Bitcoin had sort of, if Satoshi would have been able to tell the future and add all the bells and whistles that time told us Bitcoin or any sort of cryptocurrency needed, right? If you could add that from the get-go, then it would have been just the one cryptocurrency to rule them all that everybody used, and life would have been good, right? But with, different people came up with different fixes for perceived
ring signatures,
ring signatures and anonymity and all these things. And so now you have this fragmentation where like there's,
what features do you want?
500 plus different cryptocurrencies, or I don't even know, I just made up that number. There's like a very large number of cryptocurrencies, and like maybe, I don't know, the majority of them are even maybe just scams, or they're pre-mined, or there's somebody's attempt to capitalize on the buzz that
I don't know about the majority, but there's certainly some that
there's a lot of them that are weird and shady, and then there's a lot of them that are just clones of Bitcoin. They took the source code, they cloned it, named it something else, and hey, now I have my own cryptocurrency. Why don't you? So
but why don't you? The point being that there's a certain safety in numbers there that's inherent. You can build another zebra, and it'll be just as effective camouflage as any other zebra. But unless it's in the herd with all the other zebras, the lions are still going to get it.
Right. Well, so I mean, I'm not exactly sure if I agree or disagree with that analogy. I'm not even sure I got it 100%. But if you have many miners participating in the same network, then there's your herd, and you have safety in numbers, because it is hard to perpetrate a 51% attack. If you have 50 different Bitcoin networks that are all clones of each other, then they necessarily have small numbers of nodes each. So you could perpetrate a 51% attack against one of them much more easily than if they had just stuck together and not forked the software and started a separate network of cryptocurrency.
But my point is that it's not so much forking the software, it's forking the community or the amount of resources that are being dedicated to maintaining the blockchain.
Right, and
that's really the issue.
I meant forking the network, right?
Yes.
Like you have the Bitcoin network, and then you have the clone of Bitcoin, which forked the software and started a new peer-to-peer overlay community. Mm-hmm. And the software is sort of kind of almost inconsequential to the fact that they now have a separate, like, hey, this is our crypto coin network, and everybody has their own little crypto coin network. It's so easy to do a 51% attack against one of those little ones.
So just to make it clear for anybody that might not be familiar with what a 51% attack is, this is where if you have more than half of the processing power or essentially the resources, whatever is being done in order to proof of work, you can kind of hijack the history of what transactions have happened. So you can spend money and then go back and revise history and put that money back in your wallet.
So I would say in a crypto coin networks, the guarantee of being able to only spend your own money, not being able to spend somebody else's money. So like basically fraud prevention in a crypto coin network goes with the fact that a majority, more than 50% of the participants in any given crypto coin network are honest and abide by the rules. The idea is if more than half of them are cheating or more than half of them are in collusion, then they could basically rewrite history and invalidate otherwise valid transactions, and that's kind of the 51% attack.
Right, exactly.
It's collusion or cooperation between...
Well, I just want to be clear, though, it's not 51% of the number of people, it's of the resources. So you can have one person with enough resources to dwarf everybody else, they can take it. If everybody else is five containers running in the simulation, then it's doable. Right. By your training.
So if I only have 5 containers doing Bitcoin mining in my simulation and you come up with 6 Bitcoin miners of your own, then you could overwhelm the network and sort of impose your view of what transactions are valid.
Which allows us to simulate those kinds of situations in the environment, whereas that would be a lot more difficult, thankfully, on the public internet with a large traded currency. And for good reason, we wouldn't want to do that.
Right.
But we still want to be able to train, okay, how do you detect that this is happening? How do you tell that this is going on? How do you defend against it? There's a certain critical number of nodes that would have to collude in order to violate the security guarantees of that network.
In order for some unsuspecting victim to actually end up using the same organization's nodes, both for their entry and for their exit point, because that's when you could do traffic analysis and correlation and actually sort of tie the where they're going to where they're coming from together.
So just as a one final question for you, are there any Easter eggs? Is there anything in that environment that you think is really interesting that people could kind of find as they're looking around, whether you put it in there intentionally or not?
Well, okay, so the first iteration of our scraped content. So the scraped content isn't part of the open source software that we wrote. Mm-hmm. It's called TopGen and Greybox for the application, sort of websites and DNS, and for the containers respectively. TopGen is the top 500 most popular websites on the internet scraped automatically and sort of served out of this simulation. And there was, to begin with, an inadvertent Easter egg in TopGen.
So that top 500 list was filtered or just straight off?
Well, so it never occurred. So it's kind of interesting to have, people really familiar with computers and programming and the internet. We've been on the internet for a long time, and so it never occurred to any of us while we were doing the scrape that, well, the top 500 internet sites might include some content that's not safe for work. And that was
just a little bit.
That was just a huge surprise. Like, hey, wait a minute, we just scraped a whole bunch of stuff. We better sanitize this, right? So there was like an original Easter egg, and then we got rid of it because it was not the kind of Easter egg you want to be known for to your customers.
Absolutely. So, well, first of all, thank you for sitting down with us.
Well, thanks for having me.
Absolutely. And if you'd like some more information about the work that we do, or specifically about TopGen or Gradebox, please visit the website below. This has been Rotem Gutman and Gabe Samlo. Look forward to hearing from you.